Hello, this is our final video, our sixth video of F.3, and we're going to be discussing parallel and perpendicular lines here. So it's quite lengthy, it's not too bad, but the thing about parallel lines is that the slopes are the same. Now whether they're vertical, which makes it undefined, or whether they're zero, meaning horizontal, the lines have to have the same slope. So that's what it means for lines to be parallel. And here I said officially, a criterion for parallel lines. Two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. If two non-vertical lines are parallel, then their slopes are equal and they have different y-intercepts. If two non-vertical lines have equal slopes and have different y-intercepts, they are parallel. Okay? So that's what it takes to be parallel. Now if you notice the picture, two blue lines running parallel to each other have different y-intercept. Looks like one of them, it's positive y-intercept, and the other one that you cannot see right now has a negative y-intercept, but the lines are parallel to each other. They have the same slope. So we're going to do an example. We're going to show that two lines are parallel. So line 1 is negative 3x plus 2y equals 12. And 6x minus 4y equals 0. So what do we need to do? We need to show they have the same slope, but have a different y-intercept. So 2y equals 3x plus 12. So what they did was they moved the negative 3x to the right side, and then they divided by 2. So this equation, this line, has a slope of 3/2, but a y-intercept of 6. Doing the same thing with this other one. We have negative 4y equals negative 6x. Subtract the 6x to the other side. Dividing by negative 4, and it's y equals 3/2 x. And you're like, well, there's a missing number there. Well, you could fill it in with a 0. So a 0 will fill in that y-intercept. So that line has a slope of 3/2 as well. But its slope, its y-intercept is 0, which is different than 6. So they are running parallel to each other, and because they have the same slope and they have a different y-intercept. And there it is. So the green line is L1 and the blue line is L2. And if you notice, very obviously, they are running parallel to each other. Another example is find a line that is parallel to a given line. So what does that mean? That means I have to have the same slope but a different y-intercept. So what we're going to do is find an equation of a line that contains the point negative 1, 3 that is parallel to the equation of the line 3x minus 4y equals 12. So what we need to do is identify the slope of that blue line. So we're going to subtract 3x, divide by negative 4, and that's what it becomes. So y equals 3/4 x minus 3. So this line that's blue is got a slope of 3/4, so the other line has to have a slope of 3/4. But it cannot have a a y-intercept of negative 3. So let's see what we have. So the line is parallel to one must have a slope of 3/4. So we're going to begin with y minus y1 equals m times x minus x1. That's our point slope formula from a previous video, remember. So we have the point negative 1, 3, so we put that in for the x1 coordinate and the y1 coordinate respectively. And then we put in the negative 3/4 where the m, because they have to have the same slope. So what comes out of this will be our answer. So y minus 3 equals 3/4 times x minus a minus 1. So you do the manipulation. That means distributing the 3/4 and adding 3. It is y equals 3/4 x plus 15/4. So if doing the calculation, the y-intercept will be 15/4 on this one, but it was negative 3 on the other, but they do have the same slopes. So indeed, this is the equation of a line that is parallel to the blue one there and going through the negative 1, 3. So that point will go through negative 1, 3. And there it is. So the green graph is the one we just found, and the blue graph of 3x minus 4y equals 12. And if you notice, it has a y-intercept of a negative 3, and it is parallel to the other one because they're not having the same y-intercept. Okay, the last heading here is find the equations of perpendicular lines. So the criterion for perpendicular lines, Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Now remember what perpendicular means. They cross at right angles, as the picture indicates. A right angle means 90 degrees. So if you look at the picture, one of them is got a positive slope and one of them has a negative slope. And the rise is M2. Okay, so the run is 1. So that's on the blue line. That's going up. And then the other one has an M1 because it's M1 over 1. And so they're trying to show you why it's true. So finding the slope of a line perpendicular to another line. Find the slope of a line perpendicular to the line with a slope of 3/4. So if one line has a slope of 3/4 and they got to be product of -1, what has to happen? Well, let's see. So the other one is going to be -4/3. Why? Because 3/4 times -4/3 is -1. So how you kind of find that line is find the reciprocal of the slope that you have and take the opposite of it. So what we call it is a negative reciprocal. So that's the line, that's the slope of the line that you're trying to find that's perpendicular. So if you look at the blue line there, it's going to be negative. It's going to be 3/4. So the other one's -4/3. And if you do the rise over the run technique, they do appear to be right angles. So now we're going to find the example of a line perpendicular to given lines. So find an equation of a line that contains -1, 3 that is perpendicular to 3x minus 4y equals 12. So it's very similar to the previous example that I did with parallel lines, except the slopes are going to be different. They're not going to be the same. They're going to be negative reciprocals of each other. So we take the 3x minus 4y equals 12, and we're going to have to identify the slope of that line. The best way to do that is to put it in slope-intercept form. So that's what we're going to do. So we're going to move the 3x to the other side, make that -3x, and then we're going to divide by 4. So the given line has slope of 3/4 with a y-intercept -3. Okay, so what should the slope be of the line that's perpendicular to that? You're right if you said -4/3. So the line perpendicular is -4/3. Then we're going to take that slope -4/3 along with the point -1,3 that was given to me, and then again use the point slope formula. Y minus y1 equals m times x minus x1. So we drop -1 in the x1 coordinate and 3 in the y1 coordinate and -4/3 in for the m. And here it is. So y minus 3 equals -4/3 times x minus x1. So that would be minus a -1. Do the math, and it's y equals -4/3 x plus 5/3. A lot of people get kind of confused with that hanging number on the outside, 5/3. That's just the number that's going to be required in order for the -1,3 to work for that equation. So if you put -1 back into that green equation, you will get 3 from it, because it's what's -4/3 times -1? That's 4/3. 4/3 plus 5/3 is 9/3, and 9/3 is indeed 3. So that 5/3 is kind of necessary to make the -1,3 work. The -4/3 is necessary because that's the slope that's necessary to make the perpendicular to the blue line, which has a slope of 3/4. And here's the picture of it. Okay, so this is going to be the conclusion of the videos for F.3. This, like I said, has 6 videos. And if you have any questions on parallel or perpendicular lines, you need to see another example or two, get in contact with me. And that goes with any of my videos. If you need to see more, contact me, and I can either send you something through video or just something that I can just scan to you and just send it to you. So have a good day.